Hello again. So today we are going to talk about direct variation is one of the concepts that is directly related to a linear equation, linear function. All right. Actually, you don't know what a function is yet, but just think of it as a relation right now. So direct variation is basically a form of a line y equal to mx plus b. So here is we got the review. I have a review set up for you. This is all the stuff that we have covered so far. Just quickly go over that, making sure that you remember all of these. The direct variation, that's the one that we're going to talk about today, as basically is in a form of y equal to mx. That's all it is. There's no y-intercept. The y-intercept is actually 0. So all the graphs of direct variation, they always start at the origin 0, 0. And direct variations are usually useful in all of the scientific or social sciences kind of a data gathering where they look at the relation between the two variables. So with the direct variation, what it means is that between the values of x and y, or two variables, the input and output, the two always increase the same level. That means that if one doubles, the other one doubles. If the one halves, the other one is half, and so forth and so on. So suppose I give you 2 and 2, next one 4 and 4, and next one 6 and 6. You can quickly realize that the equation of this will be y equal to x because they're all the same. So the slope, that's the slope m, is 1. Now in terms of direct variation concept, we don't call that a slope anymore. It's just a different terminology. It means the same thing. We call that constant of proportionality. That means that how they are related to each other. In this case is 1 to 1. So x is 2, y is 2, x is 4, y is 4. But if I change that, let's come up with another one. Suppose this. Now you can realize quickly that in this case everything is being doubled. So when x is 1, y is 2, so that one doesn't give you a lot of information, but the next one does. Next one, x is 2, y is 4. So you notice that it's double. And therefore, once you have that set up, then you notice that you have y equals 2 times x, where constant of proportionality in here is 2, or the slope is 2. Okay, and every time you come across a situation where you have y equal to mx, by the way, some books they write it as, sorry, this is mx, I was thinking ahead. Some books will write the direct variation at y equal to kx. These the k and m, they're exactly the same, but in the world of science and social science and all of that, they don't call that a slope, so they are trying not to use m, they use k. All right, but the same idea. So this setup basically represents direct variation. And always you're going to get a straight line going through the origin. Always origin is 0, 0. And for the most case, notice that I didn't have the negative x coordinate and a negative y coordinate, because the application of this always uses positive values for x and y, the input and output. And that's basically it. So now let's look at a question. We have a table which is given to you by this right here, and it tells you that y varies directly as x. This has to be given to you. If it doesn't, you don't know the relationship and the pattern. So the first thing is that find the missing values. So notice that in this table of values we have some missing y values and some x values. But here is the thing. When you go through this, because it says direct variation, then you can actually use the table of values to come up with the other missing value. Going back to the table, there's one thing that you have to make sure that I didn't make a mistake. 6 is x, y is given to you 12, so that has to be there. All right, please put that in there. And based on that, then you can notice that, okay, if it is direct variation, notice that in order to get the 12, 6 has to be multiplied by 2. That means 5 has to be multiplied by 2, and 2 has to be multiplied by 2. So therefore this is 4, this is 10, and if that's the case, you can go ahead and notice that, oh, that looks like to me that this is, if it's multiplied by 2, that means 16 divided by 2, that would be 8, and 17 divided by 2, that would be 8.5. Okay? And that's how you get the table of values using direct variation. That's number one. Next one is, what is the slope and a constant of proportionality? Is basically that constant that you've been multiplying x by to get the y values. And in this case, we already got that. So you can call it m or k or whatever that is, whatever you can call it. But constant of proportionality, that's the terminology. Get used to that. That is 2. And then we can write the equation. Now the equation will be straightforward. So y equal to mx, or remember kx. In different books they use that, different teachers they use that instead. So all you have to do is replace k with the what you found, which is 2, and x, and that is it. That's the equation of the of this relation. And then go ahead and graph that. And graphing that should be straightforward. Make sure that you have an xy, but it is positive, so it makes sense to make it a positive value. And in this case, the slope is 2, so you go up from 0. You start at 0 always, and you go up 2 over 1, and then create another point, and then draw a line. And here it is. You got 3 points, 1, 2, 3. You can do more if you wish, but I just use any of the random points that we've had on the table of values that we got, which is right here, and then you plug it back in there, and then you'll be okay. All right, and that's basically it.